Module 5, Web3.js and Decentralized Application Development. This module will cover the essentials of Web3.js, which is the leading JavaScript library for interacting with Ethereum-based blockchains. We'll learn how Web3.js plays a crucial role in connecting Ethereum smart contracts with web applications. And we'll also explore common usage scenarios for building decentralized applications, or in short, called dApps. So what is Web3.js, right? So we have already encountered this in previous modules we have covered before, but we are doing it more comprehensively here. Web3.js is a powerful JavaScript library that enables developers to interact with the Ethereum blockchain. So you can think of it as acting as a bridge between web applications and the underlying Ethereum network, providing a rich set of functions to connect with smart contracts and to manage transactions. By leveraging the functionalities of Web3.js, developers can build decentralized applications that seamlessly integrate with the Ethereum ecosystem. The library abstracts away the complexities that you usually face with low level blockchain interactions. And this, in fact, in turn, allows developers to focus on building user friendly applications on top of the Ethereum platform. Now we'll go through the key features of Web3.js. So the first would be Ethereum blockchain interaction. So what Web3.js does is it enables seamless communication between web applications and the Ethereum blockchain. Developers can use the library to query blockchain data, deploy and interact with smart contracts, and manage user accounts with the utmost ease. Next is smart contract deployment and interaction. A core feature of Web3.js is its ability to simplify the process of deploying and interacting with smart contracts. Developers can leverage Web3.js to compile, deploy, and call functions on their custom built smart contracts. The third key feature of Web3.js is to handle transactions. It provides a suite of tools for managing Ethereum transactions, such as sending Ether, signing transactions, and this also allows you to monitor transaction status. This allows developers to build apps with robust transaction handling capabilities, which is our goal essentially, right? Finally, you can talk about account management. This library simplifies the process of managing Ethereum user accounts, including the creation of new accounts, importing existing accounts, and signing transactions with private keys. This streamlines the user experience for dApp interactions. Okay, so now we have basically covered the theory of Web3.js. Now we're going to learn how to use Web3.js, right? So first we'll have to install it. To get started with Web3.js, the process of installing it is pretty straightforward. The recommended approach is to use the popular node package manager called npm, which provides a simple and reliable way to add web3.js to your project. This is what is suggested. You have other ways too, but npm is the easiest way and it's very easy to implement. So what you have to do is simply run the following command in your terminal or command prompt. npm install web3. Very simple. This will allow you to download the latest version of the web3.js library and you install it as a dependency in your project. Once the installation is complete, you can start integrating Web3.js into your decentralized application dApp and begin interacting with the Ethereum blockchain. Okay, so the next thing we have to do is connect to Ethereum. So this is two steps: const web3 equal to require web3. So what this does is it imports the web3 library which is used to interact with the Ethereum blockchain, right? And the next step is const web3 equal to new web3 localhost 8545. This creates a new instance of web3 and connects it to an Ethereum node running locally on port 8545. So next we'll talk about working with accounts. So what Web3.js does, it provides a comprehensive set of tools for creating and managing Ethereum accounts. With very few lines of code, you can generate new accounts, import existing ones, and interact with them seamlessly. For example, the web3.eth.accounts.create method allows you to create a new Ethereum account and retrieve its associated private key, public key, and address. This streamlines the process of setting up user accounts for your decentralized application or dApp. The code example here is const account equal to web3.ethereum.accounts.create. Beyond creating accounts, web3.js also enables you to manage the life cycle of Ethereum accounts. You can unlock accounts, sign transactions, and even check the balance of a specific account, all through this very intuitive web3.js API. This flexibility will allow you to build apps with robust user account management, enhancing the overall user experience, which is our goal essentially, right? Okay, so let's next talk about interacting with smart contracts. To interact with a deployed Ethereum smart contract using Web3.js, we need to provide two key pieces of information, right? The first is the ABI, which stands for Application Binary Interface. Second is contact address. We have already gone through these terms before. Just as a quick recap, the ABI is a JSON based description of the contract's interface, which defines the available functions and their parameters. JSON stands for JavaScript Object Notation. This is a lightweight data interchange format that is easy for humans to read and write. It is commonly used for transmitting data in web applications between a server and client. So it's kind of a data structure, if that makes sense, right? We have already talked about this in previous videos. The contract address is the unique identifier for the deployed smart contract on the Ethereum network. With this information, you can create a new instance of the contract using the web3.ethereum.contract class as shown in the example code. Right? Const my contract equal to new web3.ethereum.contract, and you're specifying the ABI, application binary interface, and the address. This allows you to call contract functions, send transactions, and listen for events also emitted by the smart contract, all through this very intuitive Web3.js API. By leveraging this functionality, you can seamlessly integrate your decentralized application app with the underlying Ethereum smart contracts, creating a powerful and user friendly experience for your users. Next, we are talking about sending transactions. So Web3.js provides a very straightforward way to send Ether transactions from one Ethereum account to another. That's what you do, right? Send it from one account to another. It's a simple method, the web3.eth.send transaction method. Simple to understand, right? It's very intuitive. Web3.eth.send transaction. Everything we have done till now is very intuitive. This method allows you to initiate a transaction specifying the sender's address, the recipient's address, and the amount of Ether to be transferred. This example demonstrates how to send one Ether from one account to another using the web3.js library. We have just taken the value of one Ether. You can put any value, you can have any addresses as long as they're legitimate addresses, right? Same web3.eth.send transaction, right? You're specifying from address 1, from which account you want it to go, to address to which account you want it to go, right? Then you specify the value, right? And the value I've specified as 1 into 10 to the power 9. So 1 Ethereum is essentially 10 to the power 9 GUI, right? So that's what I've used here. So again, explanation. Address 1 is the Ethereum address of the sender. Address 2 is the Ethereum address of the recipient. And 10 to the power 9 represents the value to be transferred, which is 1 Ether. 1 Ether is 10 to the power 18 Y and 10 to the power 9 GUI. I have put it in GUI because I didn't want to write the 18 zeros of Y, so I just wrote it in GUI. Web3.js essentially handles the low-level details of constructing and signing the transaction, allowing developers to focus on the high-level functionality of their decentralized application. Next, what you can do is listen for events. Events are a powerful feature of Ethereum smart contracts, providing real-time feedback and communication between the contract and the decentralized application. Web3.js makes it easy to listen for these events and respond accordingly. The example code will demonstrate how to subscribe to a specific event emitted by a contract. MyContract.events, HTTPS mycontract.events, my event from block 0, error event console.log event. Right, so what this code snippet is doing, my contract is an instance of the Ethereum smart contract, right? And my event is the name of the event you want to listen for. You can give any event name, right? So here it's my event. The from block parameter specifies the block number to start listening from, and the callback function is executed whenever the event is triggered, logging the event data to the console. Okay, next what we are going to do is learn how to use web3.js with promises. So web3.js seamlessly integrates asynchronous programming patterns, allowing developers to leverage the power of promises to enhance the responsiveness and reliability of their decentralized applications. By embracing promise-based interactions, developers can write more concise and readable code while also benefiting from the built-in error handling and chaining capabilities of promises. So you might be asking, what are promises, right? We might have done this before, but a quick recap. Promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. Promises provide a more readable and manageable way to handle asynchronous operations compared to callbacks. That's all, right? And asynchronous functions, right? They operate asynchronously within the loop using an implicit promise to return the result. So, for example, to retrieve this balance of a specific Ethereum address, you can use the web3.ethereum.getBalance method and chain a dot then callback to handle the asynchronous response. Web3.ethereum.getBalance address then console log. Simple yet powerful code snippet will demonstrate how Web3.js allows you to leverage promises to streamline your blockchain interactions without having to deal with the complexities of low-level asynchronous operations. By adopting this approach, your app can provide a smooth and responsive user experience while also maintaining a clean and maintainable code base. Okay, so next is Web3.js and async/await. The introduction of async/await syntax in JavaScript was revolutionary. It essentially revolutionized the way developers wrote asynchronous code, and Web3.js fully embraces this powerful feature. By using the async/await syntax, you can write Web3.js code that looks and behaves more like synchronous code, improving the readability and maintainability of your decentralized application. For example, to retrieve the balance of a specific Ethereum address using async await, you can write the following concise code: const balance equal to await web3.eth.getBalance address and console log balance. In this code snippet, the await keyword pauses the execution of the function until the asynchronous web3.ethereum.getBalance method is completed, and the retrieved balance is then logged to the console. This approach makes the code more intuitive and easier to understand compared to the traditional promise-based syntax. Right? So this is what async/await does, right? Using promises with async and await makes the code more readable and maintainable. That's all this is trying to achieve. Okay, so next we'll come to managing contracts with Truffle. What is Truffle? We have already talked about Truffle in previous modules. We have used it in our code in previous modules. But Truffle is essentially a popular development framework that works well with Web3.js for managing and deploying smart contracts on the Ethereum blockchain. Something popular that you will use, right? Essentially, there are many popular things that you use in your life for specific things. That's what Truffle is. It's a development framework. There are others also, but it's the most commonly used and popular, well-known framework, right? And it works very well with Web3.js, what we are using. So this is all used to manage and deploy smart contracts on the blockchain. Truffle provides a seamless integration experience, allowing developers to simplify the process of managing their contract lifecycle. For example, you can use the Truffle artifacts.require method to load a specific contract and create an instance of it, as is shown in the following code snippet. Const my contract artifacts.require my contract const instance await my contract.deploy. So this integration with Truffle streamlines the process of interacting with your deployed smart contract, making it easier to test, deploy, and manage them within your decentralized application dApp development workflow. By leveraging Truffle's capabilities alongside Web3.js, you can create a robust and efficient development environment for building Ethereum-based apps. Next, we'll talk about error handling in Web3.js. Proper error handling is crucial, right? With anything, and it's especially crucial while you're building decentralized applications with Web3.js. This will ensure that your app can gracefully handle and recover from unexpected issues, providing a seamless user experience. That's all you try to provide. For example, you can wrap your Web3.js interactions in a try/catch block to catch and handle any errors that may occur, as shown in the following code snippet. Try const receipt equal to await web3.ethereum send transaction catch error console error. So by encapsulating your Ethereum transactions or other web3.js operations within a try/catch block, you can effectively capture and log any errors that arise, allowing you to debug and address them quite quickly. This proactive approach to error handling helps to improve the overall reliability and robustness of your app, ensuring a smooth and enjoyable experience for your users. So now we'll talk about using Web3.js with MetaMask. So MetaMask is something you must be more familiar with, right? It's very popular nowadays. So MetaMask is a popular browser extension that simplifies the process of interacting with Ethereum-based decentralized applications, apps directly from your web browser. By integrating Web3.js with MetaMask, Developers can provide users with seamless and user-friendly experience when connecting to and using their app, right? You're a developer, you want people to use your app. So by using MetaMask, you can provide them seamless and user-friendly experience to use your app, right? So the example code will demonstrate how to create a Web3 instance that connects the Ethereum network through the MetaMask extension. Const Web3 equal to new Web3 window.ethereum await window.ethereum enable. In this code snippet, window.ethereum object provided by the MetaMask extension is used to initialize the Web3 instance, allowing the dApp to communicate directly with the Ethereum blockchain. The await window.ethereum.enable call prompts the user to connect their Ethereum MetaMask wallet, granting the necessary permissions for the dApp to access the user's Ethereum accounts and interact with the blockchain on their behalf. Now let's talk about integrating Web3.js and React. Everyone's heard about React, right? It's a very popular JavaScript library. Integrating Web3.js with the popular React JavaScript library allows the developer to create seamless and feature-rich decentralized applications, dApps, for the Ethereum blockchain. By combining the state management and UI capabilities of React with the blockchain connectivity of Web3.js, developers can build intuitive and responsive user interfaces that seamlessly interact with Ethereum smart contracts and the underlying decentralized infrastructure. Import Web3 from Web3. Const Web3 equal to new Web3, Web3 dot given provider. For example, a typical integration of Web3.js and React might involve initializing a Web3 instance using the MetaMask browser extension, which provides a user-friendly way for dApp users to connect their Ethereum wallets. Once connected, the React application can leverage the Web3.js API to fetch data from the blockchain and transactions and listen for events, all while maintaining a clean and maintainable code base. Simple dApp structure. So front end is React.js, backend are smart contracts, and Web3.js is the communication layer. So the front end of a dApp is typically built using modern JavaScript framework like React.js. This allows developers to create a responsive and intuitive user interface that seamlessly interacts with the underlying blockchain infrastructure. Backend, right? So the backend of a dApp consists of Ethereum smart contracts that encode the application's business logic and rules. These smart contracts will serve as the backbone of the dApp, handling all the decentralized data storage and processing. Next, Web3.js is just the communication layer. So this acts as the communication layer between the dApp's front end and the Ethereum blockchain. It provides a robust set of APIs that allows developers to interact with smart contracts and transactions and listen for events, seamlessly integrating the dApp with the decentralized infrastructure. Okay, so now we'll take an example dApp, token transfer. This example demonstrates a simple token transfer function within a decentralized application dApp using the powerful Web3.js library. The key code snippet is as follows. Const transfer equal to async await token contract dot methods dot transfer to amount sent from sender. In this code, the transfer function is defined as an asynchronous operation. It first awaits the token contract dot methods dot transfer method call, which instructs the Ethereum smart contract to transfer the specified amount of tokens from the sender address to the to address. The send method is then used to execute the transaction on the blockchain, with the from parameter specifying the originating Ethereum account. Security considerations you have to take into account, right? So first, what you have to ensure is you have to validate all user inputs. Ensure that all user inputs are properly validated and sanitized to prevent common security vulnerabilities like SQL injection or cross-site scripting, which are also called XSS attacks. Implementing robust input validation is crucial to protect the integrity of your decentralized application. Next, we should try to handle exceptions properly. Properly handling exceptions that may occur during tap operations, such as transaction failures or connecting issues. Gracefully handling these errors can help prevent your application from crashing or leaking sensitive information to users, improving the overall security and reliability of your app. Next, you have to ensure that all communication between your dApp's frontend and the Ethereum blockchain is secured using HTTPS. This helps protect against man in the middle attacks and ensures that your users' data and transactions remain confidential and secure. Next is testing your dApp. First, what you can do are unit tests for smart contracts. Thoroughly test your Ethereum smart contracts with unit tests to ensure the correct behavior and integrity. This helps catch bugs and vulnerabilities early in the development process. Integration tests for Web3.js. You have to validate the end-to-end functionality of your app by running integration tests that exercise the interaction between your front end and the Web3.js library. Next are UI tests for front end components. We have to implement comprehensive UI tests to verify the correctness and responsiveness of your app's user interface, simulating user interactions and validating the expected visual and functional outcomes. Finally, what conclusion and further reading we get, right? So basically, we have covered the key features and capabilities of the powerful Web3.js library, and we have explored how it can be leveraged to build robust and user-friendly decentralized applications, apps on the Ethereum blockchain. By integrating Web3.js with frameworks like React, developers can create intuitive user interfaces that seamlessly interact with the underlying smart contracts and Ethereum infrastructure. Thank you very much, and I'll see you in the next video.